Hello ladies and gentlemen, this is Mr. Mayer, and in this video we will prove triangle similarity. By the end you want to be able to say I can use a two-column proof to prove two triangles similar by the angle-angle or AA similarity postulate. So our directions say use a two-column proof to prove the following. We know that there's two parallel lines and we need to prove that the two triangles are similar to each other. So again, make sure you're always starting your proof off with your given information. We are finishing the proof with our proof statement. This is the answer. This is what we want to make sure is correct or is true by the end of the table. So again, another great way to start your proof table is by looking at the diagram and deciding what kind of transformation would take the first triangle and change it into the second triangle. So starting off, I'm just going to go ahead and separate my triangles out. I see that I have these two triangles here, and I'm going to move this over a little bit so we can see the separation. So what I'm going to do is I'm going to, possibly I've got a rotation, I've got a reflection, I definitely have a dilation because there's a change in size between the two triangles. So what I want to do to kind of help me decide, is this a reflection, rotation, or what else is going on? I'm going to go ahead and start putting my information in my table to help myself out. So first things first, I always want to start with my given information. Those two lines are parallel, DE parallel to HG. Again, you want to use this information to help you create number two. I have no other given information. So thinking back to parallel lines, if I have parallel side to another parallel side, what I'm going to do is I'm going to highlight those and make sure that I understand what happens when I have parallel lines to each other. EH right now is going to be my transversal. So right now I'm seeing parallel lines with this transversal. They're creating two angles, one right here, one right here. Since those angles are located on a transversal and parallel lines, I know that these two angles are going to be congruent. These two angles are going to be congruent. The reason for that is because they are between the two parallel lines, so they are interior. One is below the transversal and one is above the transversal. So I'm using the alternate interior angles theorem to state that angle E is congruent to angle H. Now, since I have that information, since I know that for sure, angle E is at the top, I'm going to go ahead and figure out, is this a reflection, a rotation? What do I need to do so that H is in the same location as E? Hopefully you're noticing what I need to do is I need to go ahead and rotate this triangle. So right here I can see now that the two triangles are lining up very nicely. H is matching with E, and that means that F is in the same place as F for both triangles, and D is in the same place as G between the two triangles. A little bit easier to visualize now. I'm going to know that these are my corresponding parts between the two triangles. Continuing on, this does not have to be the only transversal. EH is one transversal, but perhaps you wanted to use the other transversal. So I'm going to go ahead and use, again, parallel side. This time DG is the transversal, and my other parallel side. And again, I notice that I'm creating two more congruent angles. One at D, I'm going to use two curves, two arcs, and one at G. So I'm going to go ahead and label that here, two arcs here, and two arcs here. So now I can see that D also goes with G. Okay, labeling that in my table, I know angle D is congruent to angle G, and same exact reason, still alternate interior angles. I'm using the theorem to say that they are congruent to each other. Labeling these things off to the side. This is a pair of angles. Number 3, this is a pair of angles. Be careful, make sure you understand. Number 1, this does not mean that the sides are congruent. It just means they're parallel. They travel in the same direction. So don't get caught in that confusing step. This is just parallel lines. I'm ready to go ahead and I'm looking at this information. Our postulates for similar triangles, they are different than congruent triangles. Angle-angle, AA, is one of our postulates that we use for similar triangles. So I already know that I'm going to use the angle-angle similarity postulate. I already have angle-angle, which means that my two triangles are similar. So finishing this one off, I see triangle DFE similar to triangle GFH. This is true by the angle-angle similarity postulate. And again, make sure that this is the same order as was stated to be proven. Okay, has to match. Thank you all for tuning in. Hope to see you soon.